The hyperbola. Hyperbola's basic function looks like this: y equals 1 over x. Now, remember, let's quickly recap on what a graph really is. I have a relation between y and x, and whatever value I put for x will give me a value for y. That will give me a coordinate pair. If I put all possible answers for this equation on a graph, they will form a certain line. This is y, this is x. We see that we have a restraint here. We see that x cannot be 0 because I'm not allowed to divide by 0. One of the fundamentals of maths, cannot divide by 0, which means that x can never be 0. Now x is 0 on here. So we're going to have here a thing called an asymptote. And therefore, it's called an asymptotic function or behavior because it cannot be 0. It can get close and close to 0, but it can never be 0 because I'm not allowed to divide by 0. We also have a not only asymptote, but we also have an inverse because as x is getting bigger, y is getting smaller. If x cannot be 0, doesn't matter what value I put into the place of x, neither can y be 0. So we've got an asymptote here as well, which means that the values will never be able to cross those asymptotes. So asymptotes on y and x because neither x nor y can be 0. Now, when we started doing graphs, we started with a table. So we said when x is 0, well, x cannot be 0. If x is 0, this function is undefined. If x is 1, y is 1. When x is 2, y is a half. When x is 10, y is 0.01. When x is 0.01, this thing becomes bigger. Just to show you what I mean is, if I say 1 divided by 0.01, it becomes bigger, x is then 100. So as x is getting smaller, y is getting bigger. So my graph looks like this, where it cannot touch the y or the x-axis. The other thing that happens as well is that if x is negative, so if x is -1, y equals -1. If x equals -2, y equals -1/2. If x equals -0.01, then y equals -100. So an hyperbolic function, look like that. So that's the basics of it. What we're going to look at now is when these things starts to move around. So if my graph starts looking like this, y equals a over x plus h plus k. And the same things happen here. A tells us that it's a dilation. Okay, so if I had a 2 up here, it means that for any value for x, y will be 2 times that value. So if x was 1, and that's a 2, then it's 2 over 1, which means y becomes 2. So if a is 2, this value will just push out and push out. So if x for a is 2, if a equals 2, this thing will just come out like that and like that. And if a is negative, it reflected in the y-axis. So negative a, reflection in it means your y value is negative. So that value becomes negative y. So reflection in x-axis. So a dilation and it's also a reflection in the x-axis. which means that the negative A will be there and there. Because if that's a negative, it means that if x is positive, then y is negative. If x is positive, if x value is positive, y is negative. If the x value is negative, and that's a negative on top, a negative divided by a negative will give us a positive y, and that's why the x is negative and y is positive. So that will be for negative A. K moves everything up and down. Now, if this whole thing moves up and down, then my asymptotes will move up and down as well. And I find the easiest way to explain that is when we look at a simple one like, if I have y equals, I'm just going to move the calculator. If I say y equals just 1 over x plus 3. So everything move up. So x can still not be 0. X can still not be 0 plus 3, which means that this whole graph will move up. So it will, the plus 3 will sit over there. And the whole graph needs to move with it. The h, so okay, just let me write that. K is then translation in the k value is in the y direction. In y direction. And then the last one is if I add the plus h. One more color. Y equals 1 over x plus 4. If I just look at y equals x plus 4, remember what we said, all the x values will be plus 4. X cannot be 0, which means that, or x can be 0 in this case, because if x is 0, then I still have 1 over 4. But this thing cannot be 0, because if this thing is 0, I have 1 divided by 0. And where is x plus 4 equal to 0? It is where x equals negative 4. So it means that now my graph would change, and my asymptote will be where x equals negative 4. And x is negative 4 over here. So there will be an asymptote, and there will be an asymptote. And my graph will sit there and there. If I combine all of this, you can see that h and k will tell me where my asymptotes lie. So the general rule then, I'm going to write that in red on black. So my general rule will be y equals, I actually have that, x equals a and x plus h plus k, which means that my graph will sit there. My asymptotes will be at k and at negative h. So whatever h is, the opposite direction. Remember I explained to you why that change. So it's where x plus h, which means whatever this value is, it will be in the opposite direction. Remember, if they give us an exam x minus h, then this value will be positive h, because it needs to move in the opposite direction. So that is minus h, and that is k. Please look at the examples to understand this a little bit better.